The final announcement. If you did not catch last month's meetup, this is my last meetup as co-organizer of Learn Swift Boston. Um, Poetically, it is also our 5-year anniversary. So 5 years ago, I I was struggling a lot with imposter syndrome. Um, I was working on a team with very, very smart people, and I didn't quite feel like I was smart enough. And so I remember someone, some point in my life, telling me, um, if you want to know how well you know something, you should teach it to someone. And so that is what drove me to initially reach out to Garrick, who started Learn Swift LA. He gave me the secret sauce to starting an amazing meetup, and really the secret sauce has been the community itself. Um, there were a few points over the first year that I actually thought about stopping the meetup. Um, and there's a handful of people, like I see Joe Cab in chat, who just kept coming out. It was the regulars that kept me doing the meetup. And without you all, we wouldn't have made 5 years. So thank you. It's been a lot of fun. I really enjoyed teaching what I know and helping people start their careers, and meeting so many people in the Boston scene, and now the internet with doing this on Twitch. But it's time for me to put my energy into some other projects. So I'm going to be stepping down. Zev will be taking over. We will be moving it off of Twitch. So keep an eye out on our meetup page, which is also not in links. I will give you a link to our meetup page so you can go join there, and don't have a Safari window. And you can be kept up to date with all the changes, as well as when we're meeting next. There you go. So hop on in there, join the meetup, and keep an eye out for our next event, because again, it won't be on Twitch. I believe Zev is moving it off to Google Meet, which will help facilitate some of the things that we've been talking about doing. And then Zev is hopefully finally doing them. Okay, that's all of that. No more sadness. We're talking about testing tonight. I'm going to start a new project, and it's just going to be a quick app. I'm going to call it Leap. Zev, if you can hear me, storyboard or UI, Swift UI. UI kit.
For this initial test, I was actually going to be talking just about things at the code level, so it doesn't even need a UI. It could even be a command line app if we wanted to. I don't know if that's too weird, but we're just going to be talking about logic testing for just a couple minutes, just to kind of set the scene.
Yeah, all right. Let's do Swift UI just in case.
Sure.
You can tell that I am including, or I have the include tests checked. Sometimes you see in our meetups we uncheck that just to keep the project a little bit cleaner, but today we're writing tests, so that's very important. If you have an app that you've been working on, you want to add tests to it, I can also show you how to add tests to it. You do that by going File, New, Target, and you just scroll down until you find tests, and you pick either unit tests that you want to add or UI tests. I believe today we're going to be mostly focusing on the unit tests. Maybe if there's time we'll talk about UI testing, but probably not.
Yep.
So
since we were making a Swift UI app, might as well throw in just a bare bones interface. So this will be an app that tells you whether you type in a year, and it tells you whether or not it's a leap year. We're not gonna. This isn't a session about Swift UI, so we may breeze through a couple of details. But I think last month's session on building a calculator, I think that was last month,
Yep.
Should give you a pretty good idea of what some of the things we're talking about are. But we'll try and explain as we go. So we're going to need some variable to store the text that we type. So let's start off in our content view by adding a state var. So at state, capital S, var, typed text or user text or something like that. And it starts out as the empty string. And then instead of that text, we're going to put in a text field. And it takes in let's see what the parameters are. Yeah, that one's fine. So title key, we can put year or enter a year maybe as a string. And then the text, so we need a binding to our type text so that as the user types their text, we'll update that variable. And if the variable changes, it will update the view. And then, if you resume that preview, we'll see what that looks like so far. That's a good start. And then let's add some output below. We're not even gonna have like a return key. We'll just, as you type, it'll update. So let's put everything that's in there right now inside a VStack so we can stack a couple elements on top of each other. And then below that text field, let's put a text that will say some output. So we're gonna write a function that will produce some output. So let's stub in a function that's like func produce output or do calculation or do work or anything like that. This will just be a wrapper function. There will be another function to actually do the calculation about the leap year. Sure. And it will return a string. And let's just return, foo is a leap year, or that works too. This will just be the sort of bare bones. And let's make sure that's all happy. And all of this is just to scaffold out a basic app, just so you can see where the testing portion would factor into it. I always find that talking about testing in the abstract just gets very dry and very confusing very quickly. So having some user interface to anchor it to makes sense. Okay, cool. So we have our text, and then what do we want? We're gonna want to get in that function. We want to get the text out of the text box and turn it into a number, and then run some function on it. Good thinking. And you want to run the live preview so we can actually type.
Yeah, I just wanted to not have the text field selected so I can make sure that the border was working.
Cool.
Okay. Sorry, I'm paying attention again to what?
So inside get calculation, the first thing we want to do is get the text out of the string and see if it's a number. And if it is, we'll do some stuff. And if it's not, we'll just say not a number. So maybe, do a guard. Guard let year number equals int of what's in the string. And that's failable. That will return nil if you have other stuff in the string that's not a number. So otherwise, we'll just say not a number. And then, so now we've got that year, we can do stuff. And so let's just say for now, interpolate in year into that string and say is a leap year. We'll just pretend it is always a leap year just so we can see the thing kind of coming together. Now, if you type in any number, it should say it's a leap year. Cool. And now we want a function. Hang on a second. I got to do baby stuff. Can you start stubbing out the next bit of sort of what this function might look like in a way that could be tested?
Sure. So what I'm guessing this function is the one that actually does the logic. And so this function, call it detect leap, and we'll pass in a year, and that will be an integer. Instead of calling it detect, let's say is leap, and we'll return out a boolean. If you're not familiar with the boolean, it's just like a true false yes no sort of situation, and we can return false right here. And that would let us do another guard here for the time being. Guard is leap, else return year is not a leap year. And we'll make that all caps just to make it a little bit extra clear that it is not a leap year. So we can again put in a number. Interesting. Oh, because we need to resume here. Once that's resumed, 20 should not be a leap year. There we go. And at this point, we're actually at a spot that it might be good to start writing our first test. And
that's just what I was thinking.
Hey.
I'm kind of back. Gonna be touch and go. Babies are complicated.
All right, so I'm gonna have this window in a way that you can see our app code on the left and our test class on the right. When you add tests to a project that doesn't have any tests yet, Apple and Xcode are kind enough to just sort of give you some boilerplate. If you're not familiar with the term boilerplate, it's just like some setup code, or like code you kind of gotta have.
Should we, before we go into what the boilerplate is, should we give a quick summary of just like what a test is and why you might want one? Or did you cover that?
I have not covered that. I can totally do that though. So a test, I've never actually had to define it. Actually, that's not.
I can do it if you want.
I had to do it once. Let me try.
Okay.
A test is an automated tool that allows you to verify the correctness of your code, specifically around branching logic. And so we have these guards here. You could kind of think of them as ifs, and each time we hit that guard, we have like, I could go left, I could go right, and the tests that we'll write are verifying that we're going the correct way down their code paths. How do you feel about that? Is that anything to add?
Yeah, I mean, so I think that's a good definition. I'd love to define it in a different but no more or less valid way, which is more in terms of kind of how I like to think about it, which is if you're making an app, you're going to be testing it. You know, it's not going to necessarily be automated, but like to know whether it works, you're going to try things and make sure that they work. So in the case of leap year, if you were building this app, at minimum, you would have to type in some years and make sure that they work. Otherwise, you have no idea. Like coding is just too complicated. There are mathematical reasons why you can't, you know, prove that a program is correct. So you've got to test it. But it can be slow and annoying to have to, you know, always boot up the app and try the same values over and over, and maybe you'll forget one, or maybe there's some cases that you need to test that are like hard to get that app into a state, like testing certain error cases or rare cases. So it can be very useful to set up some code that tests those cases for you, and that's what automated testing is all about, and that's what we're talking about. Yeah, that's what we're talking about. We've got a peanut gallery here. So it's about writing some code that puts your main app code into certain states, and then checks things about it. So it basically, you give it certain inputs and then make sure it gives you the expected output. That's kind of the short version is run your code through some inputs and see if it gives you the expected outputs.
Yeah. So the anatomy of a test. Let's ignore this, and let's start with just this. So for Xcode to recognize a function is a test function, it needs to, one, be in the test target. So you can see that over here on the right where it says target membership. It has the check mark next to leap test. Do I still have? I don't have. So that means that this file is in the test target. It imports xctest, which is also important. That gives us a whole bunch of functions that are used for testing, also classes, including this one that we'll talk about in just a moment. Just after that, you can see we have an @testable import and leap. This is your gateway into your app code. If you're familiar with access control levels, everything that is internal and above, so internal, public, and open, are made available to your test target through this line, where you're importing your app. That's what the leap is. In this case, it's the name of our app. And so anything that is not private, basically, we can now have access to in our test target. Also, if you're unaware, you can see we don't have public, private, internal in front of any of these things. Swift interpolates internal into everything by default. And so if we want this to be public, we just put a public in front of it. If we want it to be private, we put the private in front of it. We can put internal, but we don't have to because it's automatically there. That becomes important when you're doing testing because anything private, like I said, you just cannot access here, which can be a perfectly fine practice. You don't have to necessarily test every function directly. You should test all branching logic either directly or indirectly. And we might get to some of that a little bit. Next, every test function needs to start with the word test. Doing so tells Xcode that this is a test function, that you're going to be putting test code inside of it. That's how you get this little diamond next to it. If I click this diamond, it will go and it will build my app and it will run my test. You can see it's launching the simulator. It's running its tests, setting everything up. Everything's always a little bit slow with the stream going. There we go. Completed. We got a little thing that said test succeeded, and I've got a green check mark. There's also a test navigator on the left pane here. It shows you all of your test targets and all of your test classes and all of your test functions. So the goal is to keep everything always green. If for whatever reason a test should fail, and you can force a test failure with xctfail, you will get instead a red X. And so if you've ever heard anyone talking about testing, they might say red-green refactor. This is sort of what they're talking about. You want green tests before you write code or edit code. That will make them red. You make that red green, and then you go back in that cycle, just keeping everything green. Anything to cover before we start writing our first test, Zev?
Nope. Let's go for it. I was thinking, you already have a function that can tell whether something's a leap year, right? It's just fake right now.
Mm-hmm.
What I'd like to do, well, so first of all, let's just stand up a test that can call it at all, because I think we're going to have to figure out some stuff because it's in a Swift UI view. Things can get a little awkward.
Sure.
So you may, as anticipating the problems you might run into, we might end up making it static, which is convenient in this case, but we'll see if that happens.
Well, yeah, let's see if it does. So some of that boilerplate that I just deleted, one of the functions was a setup function. Specifically, it was set up with error. I'm going to use the one that I usually use, which is just a regular setup, but not that one. The setup function is run. So there are 3 setup functions. There is setup. This just override function setup. There is override class function setup, and then setup with error. Is there another setup with error as well? No. Okay. The one that doesn't have class in front of it is run before every test. The one that has class in it is run before every test file, just once, instead of like for each function that you have, whereas this one runs for each function that you have. And I believe that this one follows the same pattern as the non-class function version of setup. And the type of code that you write in these 3 functions is about setting up for your tests. And so Zev was talking about we might need to make these functions static. The way that we can verify that is I can make a variable that is my view, and we'll say that it is a content view. And we're going to see if I can just say my view equals content view. Let's see whether or not this works. I'm just going to quickly write a function to verify that. And in doing so, I can also talk about how you write your tests, or like a little bit more about the anatomy of a test. Every test will have at least one assertion. These are the things that are checking the validity of your code. And so they always start with XET, assert, and then what you're asserting is sort of like the anatomy of that function. So in our case here, I'm asserting that the typed text from my content view is an empty string. I ran the test with command U, which is also running the UI tests. So I'm just going to quickly disable those and hit stop. But you can still see we've got the green check here. If I say hello stream instead and rerun this test, if our setup function worked correctly, this should be a red X. Awesome. So it looks like we do have access to our Swift UI view, and
Great.
Hopefully that means all the functions will work for testing as well.
Yeah, so let's put a couple tests. Let's take a couple years that we know were leap years, like 1988, the year I was born, and 2000, which I happen to know. I believe, yeah, it was a leap year. And let's just throw in some tests for those. You
Okay.
got 200 there.
Yeah.
So in each case, we're going to let view. Oh, we have a view, right? So we can just use it. So let's do XET assert. So there's a bunch of different XET assert methods. You could do XET assert equal and assert that the output is equal to true or false. But the more specific a method you can use, the better output you're going to get in the log. So let's do, yeah, XCDSR true, my view dot is leap year 1988, and then copy that and do the same thing for 2000.
Also, I didn't mention, and I meant to, the reason you have setup functions, specifically this one that gets run before every test case. So if I hit this diamond at the top, or if I hit Command U, what would happen is the setup would get run, and then the first test would get run. The setup would get run, and then the second test would get run. The reason you do this is so that you're giving yourself a clean state for your whatever you're testing. And so in this case, if we wrote a test that entered text into the text field, called our get calculation function, and we're now changing the UI, if we had any assertions around any of that, it might not necessarily succeed the way that it should or the way that we want it to if we don't give ourselves a clean version of what we're testing each time. And so I am going to hit that diamond at the top. And I would expect that all of these should fail because I'm just constantly sending back false here.
All right. So we can write our first bit of code that actually should make this start to pass. And this, by the way, there's a bunch of different ways to do. Like you'll hear people talk about these paradigms like test-driven development or behavior-driven development, a few others. I'm not a super. I don't adhere super strictly to any of those particular rules. Some of them apply better to other languages, like. There are whole types of tests that you would write in something like Ruby, where a lot of these paradigms originated, that just don't make sense in Swift because the compiler kind of takes care of some of that for you. So I don't do strictly test-driven development, but this idea of like, I've got some logic I want to write, and I don't want to have to remember the edge cases all the time. I just want to sort of put those edge cases in while I'm thinking of them, and then have them always taken care of. That's a way that I like to use tests for sort of businessy kind of logic. So in this case, we put in some years that we expect to work. So let's go and write some code that makes those tests pass. Now, awkwardly here, we're only testing 2 positive cases. So if you actually change that to return true, I actually want to show, oh yeah, that's a good idea. Year is equal to 1988 or year equals 2000. So let's run that test. Ooh, we should use Sean's trick. We should disable debugging to make the test run faster.
Sure.
So if you go up to the scheme, which is the thing that is that thing, I don't know how to describe it, and then edit scheme under run, no, under test, you have the right idea, and then uncheck debug executable. If you want to use the debugger while you're running a test, then you have to re-enable that. But attaching the debugger to your app takes a little bit of time, and running without that checked will just be way faster, which is really nice for the stream. Okay, so now our tests are passing. Obviously, that's not good. So because we know the code is bogus in our is leap year function. So what we should do is make our test suite a little better by adding some negative cases as well. We should have it check for whether a certain year is not a leap year. And of course, you could keep BMWing the code to return exactly what the tests are expecting, but like let's not do that. And there are things that you could potentially do to mitigate that are probably out of scope for this. But if you want to look up quick check and property testing, if you want to learn more about that. So hopefully this will turn into a failing test. Wait. What happened?
The thing that I think
you
were wanting for it to be a failing test is that it should actually be something like this, which is another leap year.
Yep.
Mira asks, what is BMWing?
Oh, boy, I hope I'm getting this right. I think it was BMW. They were caught, please somebody correct me if I'm getting this wrong, but they were caught cheating on emissions tests, like how much CO2 is your car making, by detecting that their cars were being tested for emissions and doing a different thing, whether it was, running the engine differently or something like that. So like that has I don't know if it's become a meme among like code automated testing people, but like that sort of idea of like alter the code because of the test rather than to actually make it good is kind of riffing on that. Okay, cool. So we have a failing test. So we obviously need to improve our code. So let's take our first crack at it. And like when you're in like second grade and you're learning about the calendar, what is the thing that they tell you for like how do you know if a year is a leap year?
I believe
remember
is that it's divisible by 4.
That's it. So why don't we go ahead and throw in replace all that stuff with year. Do we have is multiple, or is that only on floats? Let's see if we have year dot is multiple. Yeah, is multiple of 4. If you're familiar with other languages and the modulus operator, this is the same as doing modulus equals 0, modulus 4 equals 0, but like Swift, you deserve nice things. We can have some nice function names and stuff like that. Year mod 4 equals 0 would be the equivalent in like C or some other languages.
But also Swift if you just really like percents.
Right, yeah. Okay, cool. So great, right? We've made a first crack at it, but here's a wrinkle. I happen to know that 1900, the year 1900, is not a leap year. So we should go and throw in. So that this might be like we've shipped our app, and then some users complain that it got the year 1900 wrong, and they know it was a leap year, not a leap year. So the first thing we do is put that in our tests, and now we have a consistent way to get the program to run and reproduce that condition. I did this recently on an app where a user reported when I'm doing this particular action, this bug happens. So I was able to open up a test and pipe in the. Am I wrong? Is 1900? No, it's. You'll see. We'll get there. You should check though. You should Google whether 1900 is a leap year, because if I'm wrong, then this makes no sense. Anyway, you can instrument your code, drive your code to do the particular actions, and then reproduce the bug every time rather than having to like click around a bunch. 1900, right? Okay, 1900 is not a leap year. Don't read too much, just spoilers. So it turns out the definition of a leap year is actually that if you just do every 4th year, like this is all to counteract the effects of the solar year not being an even multiple of the solar day. So you need to correct for it. It's not 365 and a quarter days. It's like 365.246 or something like that. So you actually need to do a multiple of 4 and not multiple of 100. Yeah. So a year is a leap year if it's divisible by 4, unless it's also divisible by 100.
Wait, what? That's not going to work.
Well, like 80, 88.
But then 2000 breaks.
So interesting. Yes, it does break. And so this is a really good example of this is part of the time. Spoilers behind the curtain. So this is a good example of how tests can help you, because if you didn't read the full definition of a leap year and only went with 4 and 100, it's really good that we already had that known test case. We know 2000 is a leap year. It's a well-chosen test case because it actually hits another edge case. Turns out the definition of a leap year is not just 4 and 100. It's actually if a year is divisible by 4, unless it's divisible by 100, unless it's divisible by 400. And I'm trying to remember what the right, like, you drive yourself nuts trying to write the logical statement. Is it that? Is it just if it's not? But it needs to go back to true again. I feel like the unless isn't properly represented there. I think maybe it needs to be or.
I think it is these two combined as an or. There you go.
Sorry about the background noises. It's the baby has picked up the loudest toy in the room. It's like, this is mine.
No worries. But yeah, so that works.
So cool. Great. Somebody can check and make sure. I still feel uneasy about that math being correct, but exercise for the reader is not really the point of this session. So this was a great example of how you can throw in some test cases you know about as a starting point, make your code satisfy them, and then start adapting and adjusting and checking your code with confidence, knowing that you won't break earlier cases. Like so many times I'll be late in a project and have to make some change, and I'll go, well, I don't even remember what all the different edge cases are that I've been working on for the past however long it's been. How can I be confident that I am not breaking something from early? Well, if I had a test in when I first fixed some bug, it would stay fixed when I later have to go back and refactor it. That's the ideal. It's not always like that, but it's pretty close. Also, we should see if the app actually works.
Okay.
Because that's another thing, is you can get lost in the sauce updating your tests and forget to actually see if the app works.
Nope. I'm typing here. Still typing there. What's happening?
I don't know. Simulator keyboard, I would just maybe run it because previews are bad often.
Yeah, all right. Seems like it's working.
Cool. That's pretty much the example I wanted to start with, in terms of just it's a fairly simple piece of logic, but it's also a little bit non-trivial in terms of there's some corner and edge cases, and I think that really nicely illustrates the points I wanted to about, like, you can start simple, you can expand things as you need to, you can put in known test cases to help bolster your tests, and now we have pretty good confidence. And if we think of another, like, hey, this random year is weird because they switched the calendar over for some goofy reason, we can put that test case in and have confidence that none of our other ones are breaking when we update it.
Question from chat. What is the advantage
Sure.
to having 6 separate tests as opposed to one test which leaps through an array of input and expected?
So there's definitely sort of a continuum where they're both valid. They will give you different types of output. Some people like to be really regimented and strict and say every single test has one assertion. And there's also, you'll see there's a thing called Gherkin style testing for weird reasons involving naming and puns and different languages. But that's a test of a very strict format of given, when, then, which is to say, given some starting conditions, when something happens, then this output is expected. And you would definitely want like a single test there. It can depend on the logs. If you bring up the console and show the logs of the test run, maybe make one of them fail, just like throw in a bogus number, and just so we can see the difference between success and failure. It's going to be a little hard to see because Xcode's logging is not the best, but okay, there we go. So we can see, and it's giving the format in sort of an Objective-C format with those brackets, but you get the idea that, so you can see when each test started, passed or failed, started, passed or failed, started, passed or failed. If you had one single test with a bunch of assertions inside it. I think it would. I actually don't remember. I think in a failed assertion anywhere in a test fails the whole test. I don't remember what impact that has on the log, but it's something to play with, especially if you're reading these logs. Like, if you use a build server, you don't get the nice interface to browse the logs, or inline in your code in Xcode, because if you're on some server that's not Apple's Xcode cloud, you're just reading these logs as text. So you want to like play with your success and failure messages and figure out something that's going to make your failures useful. Because if a test fails and it just says test failed, and there's nothing pointing at why it failed or what the inputs were or anything like that, it can be really hard to then go and diagnose the problem. So the answer to the question of why would you use one test with multiple assertions versus multiple tests is structured in a way that gives you a good signal to noise ratio in terms of reading your output. If you're just using it in Xcode, it may not matter that much. In fact, I would probably structure this as one test, because it's just like anytime I'm testing just a really simple transformation where it's a bunch of inputs and a bunch of outputs, I probably will throw them in an array. I actually have a blog post up. If you search for XC test line by line, maybe somebody can throw that in the chat, because my hands are busy with baby things. That is, oh yeah, you can do it. It's a little wrapper thing that I wrote that takes the idea of capturing the line of code where a test case is written and then passing that into the test function. And this lets you really easily write a big array that just has like tuples of input to output, and then you get really nice test failure messages when something fails, and it points at exactly the right line, even though they're all in an array. So I recommend that if you do a lot of this sort of transformation type testing, it can really make your test code a lot nicer. You get rid of a lot of that boilerplate I was talking about, and just focus on your inputs and outputs.
Yeah, and I think to add to that, it's also very situational. I think you could argue testing every date, make sure it works for every date. But there are a lot of dates. So like what do you have that array be? Do you have that array be just these 6 dates, 7 dates, whatever we've gotten up to? Still 6.
Right.
And like, are those 6 dates enough? I think you kind of got to find what makes sense for your test suite, because like these, for instance, at work we're close to like 5,000 tests, and it takes on the order of minutes to run the test suite. So part of those is because we're looping over arrays, part of those is because we're waiting for things to finish doing something. You kind of got to like fine tune what is the right amount of tests, what are the types of tests you care about, and that might change over time. And so you just got to kind of play with it until you get what works for you. How did this become horizontal instead of vertical like it used to be? I liked it better that way. There it goes.
That was a good question. Any other questions? Throw them in the chat.
Yeah, that was a great question. Now that we have these tests in place, Zev, where would you like to take this? Do we write tests for get calculation?
You mean in a
Just a second.
Sure. Something that I like to do in my test suites, you can see we're already starting to get a good number of tests going, is you can use something called marks to sort of organize your code. And I'm already writing it wrong because I'm trying to think and type and write. And I like to say what I'm testing. So in this case, I'm testing is leap, and I might have my positive assertions there, and then let's add in another one that is is leap is true, and then let's do is leap is false. And if I put little dashes in the front of these, you can see I get these nice little lines that tell me, okay, in this area I'm testing is leap is true. That helps if the names of your functions, your test functions, aren't very helpful, or like if you want to sort of group things in that way. I found it helpful as these files get larger and larger.
Did you talk about the symbol navigator in the jump bar?
Symbol navigator in the jump bar.
Control-6, which anybody who watched our session on Xcode shortcuts would possibly remember. Sam remembers.
Yeah.
Peppered Farm remembers.
Yeah, that's what I was just talking about.
Okay, sorry, I'm drifting in and out of sanity.
So I can make another mark for get calculation, and maybe here we want to start testing test getting calculation stops non-numbers.
Oh, this is another really good case where having one test versus many tests is applicable. So all the ones we just did are like very straightforward, just like number is leap or number is not leap. So the name of the test doesn't really add anything to that. But this function that Matt just named, test getting calculation stops non-numbers, that explains why we're running the code that we're about to write. So, you know, I was going to suggest just doing like test getting calculation and then put a bunch of tests in there, but it may not be clear then in each of those cases, like, well, why did we test this one? Like, what's the expected thing here? Why, you know, was there a bug? Is there some particular behavior? So having a named test lets us say, I mean, you can put it in a comment, but, you know, comments tend to drift out of date and generally be less visible. They don't show up in the logs. So in this case, you put the name of the test in the you know, function name, and that name shows up in the log, so you can tell all in one place when you're reading the log what you're actually trying to test. So that can be really helpful if there are specific behaviors. In this case, I think I would put these string ones in separate name functions, and I would probably put all the year ones in a single function in an array if I were doing this in my own code.
I think it also comes down to like how much you want to type.
Code is read more than it's written.
Yeah. So let's start by putting it all in one place, and we can talk about the benefits and drawbacks with it in front of us. So we'll do 1901. Oh, we can talk about all the things that I'm doing wrong.
You mean in terms of testing multiple levels?
About the brittleness of the test that I'm currently writing.
Yeah, I mean, so some might argue that it's not, like, basically we have redundant tests here. We have tests for the year logic, and we have tests for
That's not what
that
I'm
wrapped
towards.
up in another thing. Cool. Say the thing you were getting towards.
So yeah, we can, and this is sort of getting into like write the tests that work for you. Wait, what?
Cool. We have some real world debugging.
Wait, what? So when something goes wrong, you can click on your little diamond and it will tell you how the assertion failed. interestingly enough, not a number is not equal to 1901 is not a leap year.
So I wonder if this might be one of the vagaries of Swift UI. I wonder if it's not doing all its normal view updating things. I honestly don't know.
I don't know that that would matter because we're not dealing with the binding here.
Oh, that's true.
So let's pop a breakpoint
Cool.
here and let's see what's happening.
You'll have to turn back on debug executable or you will get very confusing behavior. If you want to do that in real life, maybe make a separate scheme. I haven't gone and done that because I need to double up all your test schemes. So I wish it were easier without having to change the scheme. Sean, if you're listening.
So let's pull this debug menu up and let's print out the value of my view dot typed text. It is actually empty string. That's very interesting.
It is. I think it's got to be related to the state variable and now it's a wrapper and something hasn't propagated yet. The value doesn't change until the view re-renders, something like that. I honestly don't know what the right workaround here is, other than to say, I probably wouldn't put this kind of logic in a view. And if I needed something like this to be testable, I wouldn't put it in a view. So in a real app, I would probably have this be separate in some sort of model struct or view model, observable object, something like that, that I can test in isolation without the view. And this is kind of a thing with Swift UI. Like Swift UI views, somewhat because of their declarative nature, can be harder to write logic tests for. But I think that encourages you to pull your business logic out of the view and put it somewhere else.
Well, let's do that exercise, because this is also like one of the benefits of testing right here.
Yeah, it can force you to separate your code out more, which can have benefits in terms of thinking about different pieces in isolation, which is nice. Sometimes annoying though.
So we're gonna make a Swift file, and we'll call this leap logic controller.
Sure.
And we'll just make a
should be able to get away with a struct for this.
Yeah. And we can just cut and paste our code right into there. Let's do let controller equals leap logic controller.
I believe you want that to be a state var, because you will, unless everything's going to be static, you're going to want to pass the value in, like set the value on it, and then get the year thing out of it. There are other ways you could do it, but I feel like that's the least controversial for the demo we're trying to do, which isn't really about structuring Swift UI views. But feel free to disagree.
I don't know that I want it to be state just yet. But also, why can I not find it? There we go. So then I'm going to change get calculation to take in text. Does this need to be binding?
These are now two stateless functions. If you wanted to be one of the cool kids, you could make this an enum and make those static functions.
I don't want to be.
And then never have to instantiate.
I disagree with abusing enums in that way.
Fine.
Okay. So I could run the test and I could run through all of those 6 states again to see if this works. Or I could just run our tests to see if it works. Oh boy. So my content view is no longer correct, which makes sense. Which kind of gets into an interesting conversation. I'm being very explicit here with the view that I'm testing. You might see if you're working on a project that had testing nerds in it, something called SUT, or subject under test, or system under test, depending on who you're talking to. What am I doing? I'm going back too far. So we can rename our thing to SUT so that anytime it changes, should it change again, we don't have to go modify all of our tests. Amazingly, it did not actually do the refactoring. How rude. So let's get that all in there. And then right now it's set to content view. This is going to become logic, leap logic controller. And let's rerun those tests. Our build is failing because I'm setting the type to text. Okay, so we can do a little refactoring here as well. I'm just gonna pop it in here instead of doing what I was starting to do. And we can rerun our tests. Here we go, our test passed. So this is sort of what I was talking about at the start with the whole red-green refactor, except for what you really shouldn't do, because we had a red test that we then did a whole bunch of refactoring to make it green. You should have green tests that you do a whole bunch of refactoring to keep it green. So why was I saying that the tests that I was writing is brittle? Let's say for whatever reason I need to change a value in here. I would just go change this text, and if I'm not a careful developer, which I am not, which is why I write tests, I would just move along with my day after changing that value, and then, oop, 1902 is not equal to 1901. And you can see, as I've pointed out, we've got confusing, or somewhat helpful, I guess I'll say, error logs here. You can fix that with a message that's like, this should not be a leap year. But that error message isn't going to help us a whole lot either. Because we do get that in our log, this should not be a leap year, but 1902 is not a leap year. So the test that we wrote is actually what's brittle, because we have two separate values here. We have a very stringly based test, and so I can make variables for these things. More makes sense for the latter two. so that I can then use that variable in place here. And this other variable here. And from that, I've made a whole lot stronger of a set of tests so that I can change the value that I'm testing without changing our test and breaking things.
I see what you mean about brittle tests now.
Yeah.
And I have a related anecdote to share. I worked on an app where we were pulling a bunch of amusement park data from a server and then putting it in a UI. And we were testing our view models. So we were testing, like, does the ride, like, when is this ride open? Does that string, is it formatted correctly? We were doing a bunch of like attributed string formatting with ranges and attributes and colors and fonts and things. So we were testing against all of that. And then anytime something changed on the server, we had a script that would go and pull down the latest data from the server and replace some JSON in the tests that would like stub out everything. And the problem is that every time we pull down, like if we added a new field in the server, like is this ride safe for children? Like, okay, cool, we have that new field, but when we pulled down the new values, all the open and close times for the rides would change, which means we had to update all of our strings where we didn't actually care about the times. We cared that given a time, anytime, it would be formatted correctly. So that was an example of brittle tests as well, where you're sort of updating something completely unrelated, but it has these cascading downstream effects, and designing the tests a little more separate or a little more broken down so that like you can change certain parts that you care about and the parts that you don't care about are left unchanged is a good way to think about it. Kind of plan for that.
Yeah. So yeah, the jumping back into one test function that tests a whole bunch of aspects of the function. We can write messages like this, or we can have multiple tests whose names reflect the assertions that we're doing. And so you get that sort of self-documenting, what are we testing, why are we testing it going on, which I'm pretty big about. I like very verbose test function names, so that if someone writes a confusing message here, because like, I'm not you, I don't know what was in your head when you wrote this test, I don't know why it's failing now, because this is not a leap year, and like this is all, they're both saying it's not a leap year, so what's going on? And obviously these are very simple examples. Your test hopefully maybe over time will get a whole lot more complex than this. But if this test started failing for whatever reason, like some silly developer put in the inverse assertion of what it should be, now I'm getting in our log that the test is checking that get calculation stops non-numbers. And I can be like, okay, well, they should totally say not a number, and then I can dive in and say, well, okay, well, why is this not happening? Yeah, so that's why I like smaller test functions, and then as your logic changes, you kind of like keep updating the function names or write whole new functions and delete the old functions. You know, you do what works for you in your test suite.
A mantra that I've heard is that tests are documentation.
Yes.
It's not enough to just write some code that does a test. Like, as you said, somebody else is going to read it and they have to understand it. And like, you can just go and Google whether something's a leap year, but you can't go and Google, like, in my app's particular weird domain, you know, if this user has access to this type of document and this permission changes, how do the permission flags change on this other document? Like, that's the kind of stuff that's really hard to understand. And somebody new on the project definitely isn't going to know all of those rules. So those are the ones that are often the most important to document and put in words and variable names and test method names and comments so that somebody reading it can understand not just the logic of the test, but why. Is it documenting intended behavior or unintended behavior? Is it, documenting a workaround to a bug, or, what is the purpose of this test and why was it written?
Yeah, and so you kind of, in this test suite, actually, you get 3 separate ways that you can cover that. Pick your solution. I like verbose names. Other people might like the messages. Other people still might like comments. I hate comments in code, despite the number of times that I've written them, because code gets moved around just as often as it gets written, and comments are the things that are usually not kept with the code, because it's usually above a line, and maybe I'll take this function and put it down here for whatever reason, and now this comment just doesn't make sense anymore. So I would advise against using comments to document in this way. But that's my own little rant for not right now. What else, Zev? What else would you like to cover about testing?
Well, definitely want to ask people to post questions in the chat if they've got them. Just as a way to vamp. Yeah, what else have we got? I mean, there's the idea that I definitely picked up from our Learn Swiftian emeritus Sean Olszewski, where he talks about treat your test suite as a piece of software. It's not just like you're writing this app and there's the stuff that you have to do, vegetables. Your test suite is an app, and you should treat it with a lot of the thought and care that you give to designing your real code base in terms of how maintainable is it? How well is it working? Does it need to be refactored? And specifically focusing on signal to noise ratio in terms of if a test fails, or sorry, if there's a bug, is your test suite good at catching bugs? And is it good at reporting to you that there was a bug? And if we drastically changed the math in that leap year thing, all of our leap year things might fail. It's nice if you can have not all your tests fail when a bug happens. It's nice if you can have 1 or 2 tests fail, because they can help you pinpoint where the bug is if they're well written. So just taking that level of care and thinking about what is it that I'm writing and what are the failure modes. That's kind of what you're designing for.
Yeah. Yeah, we'll give a few more minutes for questions. Otherwise, I don't have anything else, but I do have a dog that very much wants to go out.
We could definitely cut it short. We had mentioned UI tests. That may be a bigger topic than we want to get into, other than just to mention, we are doing logic tests here. We're taking little pieces of the code and running them in a test suite. But UI tests are pretend the tests can't see your code. They can just see your app, and they can push buttons just like a user, and they can type text just like a user, and then they can detect whether a certain text is on the screen. And so UI testing is at the very highest level, is everything working together? When you type your username and password and log in, do you log in? Or when you type the wrong username and password, do you get an appropriate error message in the actual UI, right? Because it doesn't matter if all the logic works if the UI actually doesn't work. So that's what UI tests are for. It is a bit of a big topic. I feel like we probably did a session on them. So if you look at the Learn Swift Boston YouTube, ! links in the chat, then you may find some stuff there. But just something to think about, that it's an option, but UI tests are cumbersome and slow to write and to run. So if you can assess the logic by itself instead, that's usually a better choice.
Yeah. Looks like no questions are coming in chat, so I guess we're going to end it early. Thank you all again for an amazing 5 years. Like I said, it's been a lot of fun, and I'm excited to see what Zev does with Learn Swift Boston without me. And I'll be watching.
Thank
you.
In the shadows. Thank you, Matt, for being the head host, and you've been a great partner in all this. And you're of course welcome back anytime.
Appreciate that, man. Really. Well, Thank you all for watching. I hope Zev sees you next month.